So in this lecture, we're going to talk about resistive current dividers. Now, you probably are familiar with maybe a voltage current divider, maybe not. But this is kind of the dual of what a voltage divider would be. Normally, we talk about a voltage divider as having a voltage source and then looking at the resulting voltage at the result of a couple resistors that would modify that voltage. Well, in this case, we're talking about a current source input coming in and us looking at a particular output of that result. Now, in this particular case, you're talking about now having two resistors, but now the two resistors are in parallel, and that current IN gets divided through between R1 and R2. Well, the question is, can I come up with a pretty routine formula to make this work? And the answer is yes, you can. Normally, we know that there's a way to do this for voltage dividers, similar sort of thing in current dividers. How do we begin? Well, you begin by starting off by saying that V out is going to be equal to the input current times the parallel combination of R1 and R2. We know they're in parallel, we can probably just use them directly. And so we know that that will give us a voltage for V out. And you think, great! But we're not quite looking for voltage, we're looking for current. So then I have to say, what is that voltage now going across the particular resistor? In this case, I'm looking for it across R2. And the question then becomes, well, okay, how do I define that? Well, just Ohm's Law across the resistor. I out equals to V out over R2. Well, that's going to simply now be, by substituting what I had for V out, IN of the parallel combination of R1 and R2 over R2. Now remember, parallel combination is defined as sort of a 1 over 1 of that quantity plus 1 over the second quantity. And of course I can do this for many, not just two, right? So that we can keep doing that. And the whole concept of the current divider would extend accordingly, sort of taking things into account. Solving that out, what I get for my output voltage then is an input voltage over R1 plus R2. And so this works out well. It's an interesting thing to think about for a current divider, that the bigger the resistor of R1, the more current I get through R2. The smaller R1 is, the smaller the current through R2 would be. So remember, in a way to think about it is whichever one has the bigger conductance is the one that gets more current, which is not surprising given that you can kind of see that I out is going to be the V out over the R2 number. So hopefully this gives you a sense, and this is definitely one of those circuits that's really good to just kind of get to memory, because you're going to kind of keep using it and it'll speed up a lot of your analysis in many places.